lesson now. Now we are taking the lesson 3 on the understanding the concept of time value of money, values and returns. Uh, so we want to learn the different techniques in the adjusting the cash flow for the calculation of the time value of money. So the basic methods are called the compounding method, discounting method. So under the compounding method, we want to use the compound interest to get that in the future value of a lump sum, future value of an annuity, future value of sinking fund, etc. So the compound value of a lump sum should be calculated using this methodology. That is, the present value of a money lump sum today should be multiplied by the present value interest factor. Present value interest factor, so which is defined as 1 plus I to the power n. So you can see an example how you can get that the future value of 1,000 rupees today deposit in a saving account at 5% interest rate. At the end of an year, you can have a future value at 2 years, 3 years, and up to 5 years. The question. But you can find out at any number of years the future value of a lump sum using this formula. So accordingly, the answer has been given to these questions in this way that you want to collect the information from the question given. So what is a P value? What is the I value? What is the N value? What is the these are the fact 3. So you want to find out the Fn values for F1, F2, F3, F4, F5, like that, something like that you want to have. So you want to define the F1 is equal to basic formula is there. So you can take that basic formula. So like this, you want to have the basic formula. So in case of this one, you want to have this formula to substitute. So in place of n, you can substitute 1, and in place of p, you can substitute 1,000. And 1 plus I 5%, you want to convert into real number 0.05. So 1.05. In place of end, you can substitute 1 to I. Right? So after writing this basic formula, you can do the substitutions and find the steps into the two steps. You want to summarize the factors and get the answer. Using your calculator, you can do it. In the second case, 1 plus 0.05. So the factor you can calculate using the calculator value. So the calculator value uh, you can use 1/05. 1.05 you can use in case of this one you can get this 1.1025. So at up to 4 digits you can have. So answer is obtained like this. So in case of third case, the factor become more. At the time you can use the scientific calculator x to the power y. So you can get it this value into the factors x to the power y. So in this case you can have these long figures. So you can use the long figure you want to round up. So here you can neglect the 0.25, the last 2 digits. Last 2 digits you want to round down. So that's why you want to, the students are making mistake on that, taking that. They are not correctly practicing it. So that's why they get the different answer. We don't give the marks to the different answers. Then in case of this, the 5, 105, you can use the x to the power y functions. So you can get that value, these long figures. So here also you want to stop up to the 1.2762. 62 up to 62 you want to stop. But you want to consider that the remaining one, the 8 is coming. 8 is coming. So what can you do is that you want to round up these figures. That means the fourth figure to be taken as the next 3. But the students are not doing this practicing it. They can just put it at 1.2762. So it's wrong. It should be 63. The answer would be wrong. So we can't tolerate that mistakes. You don't have to take a full figure as in the calculator. After rounding about only, you can multiply by 100, thousands here. So this is the right answer you want to obtain. Everyone should obtain the same answer. Right? So that we are coaching you to have this kind of thing. So this is the first calculation. That is compound value of a lump sum. So you can see in a diagrammatic presentation of the compounding valuations with the time and the future values. The future value is presented in the vertical axis, the number of years, the horizontal axis. So the rates are given as 3. Here in this diagram, you can see 3 lines, curl lines. 5%, 10%, 15%. As we have done in the example of the 5%. when you deposit the money, say 100 rupees, that is 0% here, when the year increasing, when year passing, so this is gradually increasing in values. So you see that 100 rupees is become as 150 rupees, approximately 150 rupees at the end of the 10th year. But you want to have the knowledge that when the interest rate is higher, so you can have the advantage of getting your future value at a higher level. See that compare the second curve. The 100 rupees deposited at present is become as a 250 rupees at the end of the 10th year at 10%. At 5%, 150 rupees. So when interest is increasing, it's suddenly going up very fast. Accumulation and the future value getting higher. The 15 percentage you can observe very higher. It's very cheaper. That means that the 100 rupees become 400 rupees at the end of the whole year, 4 times. 4 times. Hmm. So the double your money, 4 times, 2 times double your money. So you can learn that when the interest rate is higher, the bank provides and everything, you can get your money growing very fast, growing very fast. If it is 100%, what will happen? At the end of the 1 year, you can have the 200 rupees, 100%. So very sharp, perpendicular curve you can have. So from this picture, you can easily understand the compound value, then the behavior of compounding values, and the relationship between the interest rates and the future value. When the interest rates are getting higher, the future value compounding accelerated. Then you can learn another concept, compound value of an annuity. So it may be new to you. What is the meaning of annuity? Annuity is a fixed payment, or is it each year for a specific number of years? So in the practically, you can have the example for annuity, rent. What do you mean by rent? So when you are letting your house for rent, you should determine the fixed rate, right? So you are the higher people, the rent out people should pay you the fixed amount on monthly or yearly basis. They can provide. So it is called annuity. And the payment type, loan payments. Sometimes the bank may require, if you take a bank loan, say 1 lakh from a bank, the 5 years loan, 5 years loan. So the bank may require you to pay the 5 year loan within 5 years along with the interest. So they can calculate and request you to pay 25,000 each year. For 5 years, you want to pay 25,000. That becomes as annuity to pay off your 100,000 rupees. So when you compare the total, you want to pay 25 into 5 years, 125,000, but your loan is 100,000. So 25,000 is the difference. That accounts for interest they charge. So we don't worry about that, but you want to understand the example of the annuity, the fixed payment or receipts. Don't forget that. The future value of an annuity should be calculated using some methodology for an period at a high rate of interest. These are the two variables, number of years and the interest rates are the powerful factors in determining any value of this. So how can you formulate formulate a formula to calculate it? It's very difficult for you because we want to get that idea from the scholars who found that idea, the formula earlier, and we are just to adapt this learning. So we don't have to formulate. We don't have to formulate any formula now. We want to just memorize the formula and put it. See that formula. Hello. Good morning. Yes, sir. அதான் நீங்க இன்றைக்கு வாங்கலாம் ஒரு 9:30 எத்தனை 10:30 ஏன்னா இந்த பக்கத்துல இருக்கு 40 பேர் போடலாம் நான் நீ பார்த்தா 40 வரை இருக்கு வாங்கலாம் மேனேஜ் பண்ணலாம் இந்த ஜிபியா போடுவோம் இது அந்த இது இருக்கு உங்களோட இது கொண்டு வரீங்களா என்னது இது வைஃபை ஒன்றும் இல்லை நெஞ்ச வைஃபை இருக்கு மண்டபடியா இதுல ப்ரொஜெக்டரே இருக்கு இந்த கொப்பி புத்தகம் எல்லாம் கொண்டு வாங்கலாம் எல்லாரும் இருக்கு எல்லாரும் கலைக்கு வாங்க Right, student, you want to keep a notes with you, right? Lecture notes with you, because while you are learning, you want to do the practice also. Right? You can't depend on the notes to be uploaded. So you want to keep and do some practices. You can't just see and listen. You want to work along with that other instruction given to you. So everyone, take your note, make a book to some extent. Later you can find the slides uploaded. Now you want to work on that. Right, everyone take down this formula. The exercise by under the title compound value of an annuity. Other things you don't have to take, only the formula you can take and work out with that example. So what is that? If n is equal to A, it means annuity. 1 plus I to the power n minus 1 over I. So everyone should memorize this formula for annuity formula. Sometime you can find it in the present value table. on the top of this. But better you memorize it. So all the time memorize and rewrite and keep it in your mind. A into 1 plus I to the power n minus 1 over I. So there's a the ready-made method also is there. Yeah, you want to keep with you to that the present value tables with you. So that is called the Fn is equal to A into CVAF. Compound value annuity factor. Compound value annuity factor. So in some table it is named as differently. I construct it. Everyone take down this kind of the shortcut. This is feature value interest factor for annuity. So you can have this in the format like this. Feature value interest factor for annuity. FVIFA. FVIFA. Or simply CVAF is there. Now what can you do is that you want to copy down. In the exercise book, copy down this example for a future value and annuity. Suppose that a firm deposit 5,000 at the end of each year for 4 years at 6% interest rate. How much would this annuity accumulate at the end of 4th year? Usually, your parent or you may deposit certain amount, out of salaries at your bank account, at your name or the parent's name. They can put. They can deposit monthly or annually. Put it. Uh, so it would be growing. So when you are coming to at the stage you are getting married, they can withdraw and spend the money for your the ceremony. So this is a kind of deposit they can make certain amount each year. So in the earlier case, only one time. That is called lump sum. Rather than putting the small amount of money every year, They can put big money at the end of the year, at an year, and let it grow for a long time, and later they can withdraw it. But this is different. This is called annuity. Right. Now you want to find out this answer to this question. How much this annuity accumulate at the end of the fourth year? At the end of your degree program, you want to get it. So you want to collect the information from this. So what is 5,000? 5,000 is annuity. The end number of end 4 years. I interest rate 6%. So you should be able to convert the 6% into a normal figure. That is point not 6. Sometimes you can get confused over it. So there's a method for it that you take 6 divided by 100. Then you can get the results. So if your brain is not good to calculate this one, so you can use calculator to get it. Sometimes the people may take it as 6%. Then everything is wrong. Or some people may take it as this amount. Not 6. So better you confirm with your calculator after you convert. Then what is it to be found out? F4, how much F4 value. So you can substitute your original formula or this the table value form. I think better you practice applying both. So what you want to do is that you want to get that the formula. So you want to write this formula and do the substitutions. First, write about the formula. And do the substitution. For A, how much you can substitute? 5,000. 5,000 you can substitute. 1, okay. For I not 0.6. For in the You want to substitute 4. I again you take the uh, real number. Don't take it a percentage. So that's all about. Mm, right. Now solve it. You apply your basic mathematical steps in solving these in the several steps. Or you can get the direct results also. It's better that you go for this steps initially. What would be the steps? Uh, you can summarize these ones. Huh? So you want to take 1 point. 1.06 to the power 4. So this is coming. E coming here. You want to minus 1. Then the remaining is there. Plus 1. Oh, okay. Yes. Then you want to divide it by point not 6. So you can get this figure. For point much? Sorry, copy it. 3746. So the value is into 5000. So 21,800 and 73. So in this method, you get the answer 75. Mhm. So the problem is coming with the this long digits. Four six one six. Yeah. Yes, this is wrong, huh? So three. Right. So students, you can observe that there are two methods to get that answer. One applying the direct formula given. Hmm. Then you can substitute and you want to round up the digits to these factors. This is called the CVAF 4.3746 pound. So alternatively, you can apply this method from the table value. So you can go to the table. The A2, table A2, table A2 is the future value interest factor for $1 annuity. This formula is given here. So in this case you can find at 6%. At 6%, this amount is already calculated. You can see it. So this amount is there. That is at 6%, the fourth year, this amount, is coming. 4.3746. So even though if you are using your calculator and apply the formula, you want to convert all your answers in these formats, the final format like this. If you have this in the extended figure, your answer would be different. Okay. So everyone get your answer either by applying this formula or this the direct the table value formula. I think if you are practicing on the table value formula, it would be easy for you. So you can save time in answering your question. So next thing you can observe that the diagrammatic presentation of this the annuity calculations. So this is the first case. The first rectangle, you can see that 0, starting point 0, then 1, 2, 3. These are the years. End year. End year. At the end of the year, you deposit 1,000 rupees. Second year, 1,000 rupees. Third year, 1,000 rupees. This is the way. So the interest is provided. Interest is provided at the end of the year. Starting from this, the third year, not compound, because you want to calculate the compound value of the annuity at the end of the third year. So in the first year, it is not compounded. It's not compounded. Because this is the same figure, not yet the interest provided. But in the second year, only 1 year interest is provided. So interest is 8%. So 1,000 on 88%, 80 rupees. 80 rupees added. For the amount deposited at the end of the year, it is compounded with a 2-year interest. The first year and second year. So it's become 166 rupees. Interest plus interest, interest on interest. So meaning that mm, 1080 into 8%. So 1166 is coming. So adding all these things give you the total value of an annuity of thousands deposited at 8% at the end of the year. This is coming. So if you forget that answer, the formula, suppose that you are not able to calculate that these things, what can you do? Now, example, the 5,000 is there. You want to get this 21,881 for 4 years. So what can you do is, you had a simple formula. What is a simple formula? So you have 1, 2, 3, 4, 4 years. So every year 5,000, 5,000 deposited. Right? So you know that the present value, the future value 1 plus R, 1 plus R, 1 plus N, 1 plus I. So first one, the 1.08. Second, second 1.08 squares, 1.1664. Good. Third would be 1.08. Sorry, and not data, not 6, our things. 1236. The third one, the 1.06 to the power 3, 1910, 1910, 1910. Fourth year, fourth year, 26, 25. Cannot be right now. Right. Okay, you can confirm that. So this method, compounding it individually, compounding and individually, you can get that as the same value. So you want to go by the reverse. So the current year deposit is at the end of the year, it cannot be compounded. So you take only one. The third year last year converted should be given as the 1 year. N is equal to 1. Second year 2. Third year 3. So you get the value for this normal the future value factors and multiply it and adding together, you can get that the future value of lump sum. You can learn it. So the lesson will be continued later with other uh, examples also. Discount. The 2 hours lectures will be scheduled. Later you can attend it.